We want to make sure that this model is exactly symmetric along the x-axis. Of course, you always can symmetrize any mesh by first deleting one half of it, and then use a mirror modifier to reconstruct the complete mesh. However, here I want to show you how you can inspect the mesh, and how you can fix it when necessary. Let us first check where the object pivot is located. Open the Properties area and check the translation values of the mesh. Yes, that seems good. The pivot is in the scene center. Let's go to Edit mode and select all vertices of the mesh. Now inspect the median of the selected vertices. It is shifted sideways by more than half a centimeter. So let's compensate this shift by moving all vertices as follows. First, type G. Then immediately left-click anywhere into the view to finish the transformation. Now open the tool shelf, and there, locate the Operator Redo panel at the bottom. Now select the X value of the median. Then, copy the value into the paste buffer by typing Ctrl+C. Next, click somewhere into the view to finish the copy. Finally, select the X value in the Operator Redo panel. And now paste the value by typing Ctrl+V. Then remove the minus sign from the value, to compensate the shift of the mesh. Finally, press the return key. Now you can see that all vertices have moved sideways, and the mesh is now at least visually centered. Let's get into more details and see if the mesh is really symmetric. We now use the Avastar Symmetry tools to inspect and fix the mesh. Open the Avastar tool shelf. There, open the Toolbox panel and click the Asymmetry Finder to select all asymmetric vertices. Well, this does not look very promising in first place. But don't panic, Blender has a symmetry cleaning function for our rescue. You can activate this function by clicking on the double arrow on the right side besides the Asymmetry tool button. And now, your mesh got magically fixed. However, there is a pitfall. Let's open the Operator Redo panel at the bottom of the tool shelf. Then set the symmetry factor to 1, to get a full correction. Now look at the symmetry threshold. This value influences how Blender finds the mirrored vertices of a mesh. If the value is too high, then Blender will always find asymmetry and can easily mess up your mesh, especially when the mesh is actually not symmetric at all. And when the range is too low, then Blender won't find any mirrored vertices and just does nothing. Okay, so let's begin with a range of 0.5 millimeter. And do not forget to enable the center option. If you fail to do so, then all vertices close to the mirror plane will be ignored and not fixed. Now call the Asymmetry tool again. If we look very closely which vertices have been selected, then we can see some vertices on the hands are affected. But the majority of vertices can be found close to the vertical center line of the character. Let's ignore the hands for a moment, and only fix the character on the back and on the front. Disable the limit selection and deselect the vertices on the hands. Then call the Symmetrize tool again and set the range to something like 1 centimeter. Also, do not forget to enable the center option again. Now the mesh is almost symmetric regarding its vertex locations. We only have to fix the vertices on the hands. Let's open a second 3D view, so that we can see the details of both hands at the same time. Make sure that the properties area is visible on both views. Now let's transfer the locations of the affected vertex from the left thumb to the right thumb as follows. Call the asymmetry finder to see which vertices are affected. Then select the vertex on the left thumb. Snap the cursor to the vertex location. Now change the sign of the X value of the 3D cursor location. Now select the corresponding vertex on the left thumb. And finally, snap the vertex to the cursor location. Now check the symmetry again. And proceed in the same way for the other vertices which still are located at the wrong locations. Now the thumbs are fixed, and another check shows the mesh is now fully symmetric regarding the vertices. So we now can proceed with the edges as follows. Enable Edge Select mode. And then check symmetry again. Now we see that some edges are actually not symmetric. Let's see where they are. Okay, the problem is located somewhere in the eye sockets. Let me switch to Face Select mode. Then select just the troublesome mesh parts. You can do this by hovering the mouse over a part, and then press L on the keyboard. When you have selected the areas of interest, then invert the selection by pressing Ctrl-I. Then hide the selection by pressing H. Now we can easily inspect what exactly is broken. Switch back to Edge Select mode. Use the Asymmetry tool to find the broken edges. And now switch to Vertex Select mode. A closer inspection shows us what is wrong here. Some vertices have exchanged their position. Let's fix this now. Here I show you another little trick. First, enable Vertex Snap mode. Now select one of the vertices and snap the cursor to the selected vertex. Now move the just selected vertex towards the other vertex until it snaps. Then select the other vertex. And finally, snap the vertex back to the cursor location. By now the two vertices have exchanged their location, and this seems to fix the issue. Well, we still have another problem with exchanged vertex locations on the other side of the mesh part. Let's fix this in the same way as we just did before. Now let's make a final test, and check the symmetry for all three select modes. Unhide all vertices by typing Alt-H. Then enable Vertex Select Mode, and call the Asymmetry Finder. Now enable Edge Select Mode, then call the Asymmetry Finder again. Finally, enable Face Select Mode, and call the Asymmetry Finder yet another time. Perfect. The Asymmetry tool no longer finds any asymmetries in the mesh, so we can be sure the mesh is symmetric by all means, and we are done. Thank you for watching, have a nice day, and hopefully see you next time.